Hi, good morning. Today, excuse me, today is December 13, 2025, and it is 8:32 a.m. So today is Saturday, December 13, and it is 8:33 a.m. U.S. Central Time. And my name is Rinaldo J. Aguiar Marcano, and I'm recording this video from my home, located at the 2302 Britton Ridge Drive, Katy, Texas 77494. And this house is located in a gated community called Lake Point Estates, which is uh, my house is located 300 feet away from the house of Robert Mueller, who was a director of the FBI for several years, many years ago. And both of our houses are located very close to the house of somebody by the name Miller, who is a prominent intellectual property attorney. And although this might sound like random comments, this is very relevant to this conversation. Um, in fact, let me show you where the house of Miller is. Um, so here's the directory that Phil Denning gave us. Um, yes, so his name is Blair Miller. And the house is the 14903 North Point Place, Katy, Texas 77494. Um, so to show you this, oh, let me share my screen with you. I haven't done that. Mhm. So to show you that graphically, Mhm. Right. So this yellow marker is my home. This red marker over here, the 24926 North Point Place is Robert Mueller, and the Miller house is 14903. No, that's not the house. Mm-mm. It's this one. 14903. So the OCR had made a mistake. It took the 9 as a 1, but it's not a 1. It's a 9. So the house of Miller is 24903 North Point Place. Um, let's make sure that we have the right house. So let's go to Fort Bend County tax. Um, Property tax. Yes, yes. So his name is Blair, right? Let's see. Terrell is his name. Blair is probably the wife, right? He's a prominent intellectual property lawyer, like the ones that the PayPal mafia and the Communist Party of China like to use. Yes. anyhow, yeah, so that introduction is although it may sound like a random comment, it's important and relevant to this conversation, right? So today, for this demo, so what I would like to do is to kind of do a second session, very similar to the demo 91-8, right, that I recorded recently, which was a code lab. So this is going to also be a code lab, but it's going to be kind of a continuation of the previous one, because in the previous one, what we really did, like I didn't explicitly say it, but I'll say it now. So what we really did was to work on the retrieval problem. Okay, so in information retrieval systems, usually, when you work in these things, in these problems, it's a multi-step process, right? Because it's a very complex problem to solve, and you need to do it in stages. So the first stage is usually called retrieval, which means that out of a sea of information, you are picking the right ones, like the ones that are relevant to the problem you're trying to solve. So that's what we did in the previous session. If you think about it, right, out of all the court cases in the first court of appeal for an entire year, we pinpoint 92 lawyers, right, out of probably 1,000 or more, actually 2,000 lawyers, right, and pro se litigants that interacted with our court over the course of the year, or over the first 11 months of the year, because the data is from January to November. So out of all of them, we pinpoint 92 players, right, that are important. So that is retrieval, right? And we did some lightweight ranking, we call it, because we ranked them by the score in the U index, right? And that's how we identified, what's his name? I think it's Chris Branson, I think is his name, right? That prominent attorney that works in child protective services cases, and that has more than 32 million points in the U index, right? Attributed to him directly. But that is just part of the problem, right? There's a lot of other information that we can use that is embedded, right? We can derive more signals from that data set and do more sophisticated ranking, very similar to what the app that the Communist Party of China developed over the last decade or so, right? So in this session, what I would like to do is to offer you like the second step, like how to do ranking on this thing, right? So it's going to be a code lab, okay? I'm going to try to do it quickly, because, I don't want to do a super long session, because I know that will deter people from watching it, right? In fact, recently, right, I offered somebody to watch it, and they say, well, 3 hours is a lot of time, right? Like, so I'll try to condense it as much as I can. So I'll get it started, but that's the goal, to do a code lab like that. And I also have some observations that I've been meaning to record, and I haven't had a chance to, so I'll take this opportunity to do that at the end of this session, right? So I'll start this session as a continuation of the previous one. So if you have, so this will be demo 91-9, right? So this is the 9th part of the series of demos on the 91 series. So if you haven't watched the 91-8, please watch that one, because this is a continuation of that. So that it's kind of a prerequisite to understand what I'm going to say here, okay? So in the previous code lab, right? Just want to make a quick observation here. Right. So in the previous session, right, what we did is that we took all the court cases of the first appellate court, where Chief Justice Terry Adams is the top justice in that court, and we took all the cases for the period from January to November 2025, and we extracted data from those public records, including the addresses of the attorneys and their law firms, the attorneys that were involved in those cases, right, on either party. And then we joined that data, those locations, those geographical locations of those attorneys and their firms, with the geo index that was leaked to me by the Venezuelan intelligence on 2024. that has crypto payments recorded in that database, right? We joined the data, and the condition we used for the join was that the address of the firm or of the lawyer had to be within a circle of up to 100 feet radius from the points marked in the index, right? With those crypto payments or espionage scores. So geographically speaking, it's a very restrictive condition, right? And we restricted the data set of the geo-index to only the Houston uh, metro area, right? So more or less this area that I'm showing you here, right? And when we did this process, right, there were something like 2,500 rows in that database because certain cases had multiple attorneys, right? There's cases that have 2 or 3 attorneys for a party. So the observation I want to give you is that, in fact, let me open that. Right? So this is the list of attorneys that I'm talking about, right? And you can see the points here, right? So these points correspond to these 92 attorneys, okay? In fact, maybe I can choose a different type of chart that is like a more discrete chart, because this is a heat map. And right, so here you can see it more as dots, right? You can see the dots. So basically each dot represents an attorney, right? Or a firm. But the thought is, right, if you think about, I mean, I want to tell you, right, I want to tell you what is the statistical significance of this, because it's a subtle thing, but it's important to highlight it, right? So look at this huge geographical area we're talking about. We're talking about the entire Houston area. And look at the huge data set. It's 2,500 possibilities, right? 2,500 rows in that database that I'm describing that we joined with the geo-index. Now, out of all those possibilities, I mean, the 2,500 rows, each one had a latitude and a longitude, right? So 2 different numbers with a precision of 7 digits, right? So we're talking about GPS locations with a precision of meters, right? That's the precision that is recorded in that database. Like, uh, let me create a new page, right, to show you what I mean. So I want to make a copy of this one. Actually, before I do that, let me do something. And this is generally a good practice. When you work in these dashboards in Looker, once you get a dashboard that you like, it's a good idea, if you want to modify it, don't modify it, but make a copy of it, and then modify the copy. That way you have kind of you don't damage the one, if you made a mistake, if you make a mistake, you don't damage the one that you already created. So I'll do that, right? I'll make a copy first. I'll copy this report to a new report, and then I'll work on that one, right? So I don't damage the other. Okay. I'm going to name this part 2. Okay. So here, I'm going to make a copy of this page. Okay. And I'm going to create a new table. I just want to show you more or less in a more structured way, what data is in this table, right? So this is the table that has the join with the crypto payments. So I'm going to remove the address. Okay, and I'm going to remove this metric. And I'm going to add the actual case number. Right. So this is the case number in the first court of appeals that you're seeing here, right? And this that you're seeing is how many individual attorney entries there were for that cause number, right? And this may be a good point to tell you this. Like in the previous session, right, I talked about indistinctly about the rows, and it may sound like I'm talking about the cases, but I'm not really talking about the cases. I'm talking about the individual attorney entries. And this is, I mean, the reason why I did not make that explicit distinction is because this is too natural to me. Like I immediately go in this direction, and I should have said it because it's not an obvious thing. Like for a person that is not familiar with this work, with this type of work, it's not obvious, right? This is a technique called smearing. Okay, the idea of smearing is that you may have, how do I say this? You may not have enough information about a thing, but you can smear information that you have about things that have interacted with the thing you want to understand and attributed them to the thing. Right? I know it sounds complicated, but to give you a concrete example, think about the cases, right? I may not have, I mean, I could read the cases, right? Or use an NLP to analyze them. I could develop understanding of the cases, and that's something that I need to do. Like that's an important part of this ranking work. I need to augment this with signals about the dockets, right? But I haven't done that yet. But if you think about it, right, just looking at this table that has the attorneys only, right? So it has the case number in the appellate court and the attorneys, and metadata about the attorneys and the firms, like the addresses and the locations, right? The latitudes and longitudes. But about the cases themselves, I don't have much information, right? For now, right? But that doesn't stop me. Why? Because I can smear signals from the attorneys to the case, right? The idea is, if you think of a case, the attorneys that participated in that case tell you something, right? For example, if it's a case in which both the appellant or the realtor, the realtor and the real party in interest, the attorneys of both sides are marked in the index, right? That tells you something, right? There could be collusion among all these people, right? It's just an example. But the idea of smearing is that you can, by proxy, score something by using signals that you really derive from things that are related to that thing. In this case, the things that are related are the attorneys, right? So what I'm doing intuitively is smearing signals from the attorneys to the case, right? That's how the case gets flagged, right? At least until now. So this is smearing. So when I talked about these rows, in reality, these are not cases. These are attorney rows that are tied to a case, right? It could be that there's multiple cases. It could be that there's one case that had 15 attorneys, right? Either, there's two situations, right? You could have 15 separate cases in which attorney, I don't know, Branson is present, right? Or you could have, and that, those 15 cases would be tied to him, right? Or another situation is you could have one case in which you have 15 attorneys interacting with the case and all the 15 attorneys are marked, right? That makes that case relevant as well, even if it's only a single case, right? So this technique is called smear. But going back to the data set, we have the case and the same with the parties, right? So there is a field for a party. See? And here you can see, right, that this is a good example, right? So this transocean deep water drilling, transocean offshore deep water drilling has two dockets, right? Two cases with different numbers, but the number of attorneys that are in those dockets that are also marked in the index is huge, right? That's where the 16 number that we saw, the number 16 that we saw before came from smearing the number of attorneys, the signals related to attorneys that are marked in the index that are in these cases. So the number of cases is not huge, but the number of attorneys that are marked in the index that are in those cases is huge, right? Either way, it's damaging, right? And I didn't know this in the last demo, right? But when I saw the demo, the name of the company, right, this deep water, is stuck in my head. And then I researched it afterward, and this is the company that was related to that explosion of that oil rig in 2010, and they were fined by the EPA for 1.4 billion with B dollars, right? So that's why they're litigating this thing in this specific court, right? Because this court is controlled by means of the Adams, right? And of course, I'm going to send these demos to the EPA, right? Because probably they may want to investigate this thing, right? Like these attorneys, right, that are interacting with these dockets and this company, right, that was fined by the EPA. So I'll take that step for sure. Okay, but going back to the demo, let me see. So you have all those fields. So what I was the idea, the thought I wanted to give you, right, is that if you see here, for example, if I show you the latitude, right, you see these latitudes have up to 2, 4, 6, 8, 10 decimal places, right? Up to 10 decimal places. I mean, this is something with the precision of feet, right? 2 feet, something like that, 2 foot. So these are high precision coordinates, right? But the interesting thought that I wanted to leave you with on this part is that look at this huge geographical area, right? And the database of Elon, this database, the GeoIndex that the Venezuelan intelligence handed to me last year, if you join those data points that are marked with those crypto payments with this high precision geolocation addresses in the data set of the attorneys that are interacting with the First Appellate Court, out of the 2,500 rows, only 92 match, right? So this tells you intuitively that matching this join is not, it cannot be random, right? It's not a coincidence, because they will say, well, no, this is a coincidence. Like, we don't know who produces database, but we have no idea about this, right? But this cannot be a coincidence because this geographical area is huge, right? I mean, think about the entire Houston area, and we're saying that they match the locations of these attorneys, and these are the locations that they have registered with the Bar of Texas, right? These are not locations that I came up with. I got these addresses from the Bar of Texas. They filled a form with the Bar of Texas, an official form, and registered those addresses, right? So they're responsible for that address being in the Bar of Texas, with the registered in the Bar of Texas. Like, I did not put that in there. They put it in there. And those addresses that they gave to the Bar of Texas, to the Texas Bar, match within 100 feet these prominent points in this database that the Venezuelan intelligence is using to bribe people, right? Well, to keep track of the bribery, right? Really. Because, they need to have an accounting system, right? They can't, they care about the money, right? But think about, right, what are the chances that, statistically speaking, right, what are the chances that out of 2,500, 92 only match, right? And those that match, if you look at the distribution of the scores that they got, right, and you can see that by clicking on this page, right? Sorry. Right? If you look at the distribution, right, the top one has 32 million. The second one has 5 million. So this looks like a bell curve, right? This is not, and this is what you would see, for example, in a ledger of an accounting ledger, right? Like, some people get paid way more than the people at the medium, and it's a bell curve. If this was a random thing, right, you would see that all the numbers, you would expect to see noise, right? Like all the numbers have more or less the same values and there's no clear outlier, right? If this was a static noise, right? So what I'm trying to convey is that these two observations, right, that the matches in the geographical area are so precise in such a small area among a huge geographical area of possibilities. And secondly, that the points that they combine in these firms and the locations of these firms and these attorneys have a belt distribution, that it's unlikely to be random. Right? This is not random. There's intelligent design behind this, and you can see this. I guess what I'm trying to say, show this. I mean, if anybody comes across this from the authorities, show this to a statistician that is not working for the network. Right? I'm talking about potentially the FBI or I don't know, the Secret Service. Like, show this to somebody who has understanding of statistics, and they will be able to see that this is a smoking gun. Really. This is what it is, right? Because they're gonna claim that this is a coincidence, that they're marked in that database, but they don't know why, right? But I think a statistician will be able to see past that, right? Argument. Okay. So that was one comment I wanted to. So to give an idea, right? That geographical area where I did the matching measures 10,000 square miles, right? I mean, to put it in concrete numbers, that's 10,000 square miles. And out of those 10,000 square miles, and 2,500 candidates in the first appellate court attorneys that interacted with the court during 2025, out of those two universes of possibility, there were only 92 that match both on latitude and longitude. Those numbers having a 10 up to 10 digits decimal precision. And both have to match. You cannot only match the latitude or you cannot only match the longitude. You have to match the two of them. The probability of that happening is infinitely small. Right? I can do the math. Right? It will take me a few minutes, but it's in the 1 in trillions, right? That this is random. Precisely because that area is 10,000 square miles, right? And the matching condition for the joint is very small. It's 100 feet. So anyhow, the other thing I wanted to mention, right, is the other thing that tells you, right, and I'm saying this more than like to show a proof of anything, but like because this is concerning, right? So when I do this exercise in the last session, the lawyer that came on top in terms of the score of the crypto payments is this person, Chris Branson, right? And in the previous demo, I looked him up in front of the the recording, and this person works in child protective services, right? And what I'm going to say is not because I'm going through this situation, right, with that they caused. That's not the reason, but I mean I cannot. It's impossible for me not to connect the dots, right? So I mean, the observation is that all of these 95 attorneys, that as I said, right, this is not a random thing. Like, and you can see by all these statistical metrics that I'm offering you that there is design behind this. But across all the 92, the one that has the highest score and with one order of magnitude above the second highest score is this person, Chris Branson. And he happens to work in child protective services, right? And remember, I documented in the books previously how this network was doing this thing where whenever I went outside, they would bring a child and put it next to me, right? And then take pictures of the child next to me, like things like that. So, I imagine that, what this signifies or what this hints, like, I mean, this is something that needs to be investigated, right? I'm not an investigator. I don't have the tools or the, to make that call, but somebody needs to investigate Chris Branson, right? Whether he is being used to weaponize children, right? Because since it seems obvious to me because of the things that they've done to me personally, the ruses that they've tried to do, right? And the fabrications, really, that the Communist Party of China sees American children as weapons, right? As weapons, or at the very least as tools of coercion, right? So, the fact that this lawyer has 32 million points in this crypto database, and he's working on child protective services, and he's litigating things on the First Appellate Court where the Adams are working, I think that calls for an investigation of this person, and not only of the person, but all the cases that he has been involved in, right? To see if another parent has been deprived from their parental rights, right? To see if he has made claims about, you know, uh, improper interest in children, right, against another person. I mean, the things that they have tried to do, right? Because obviously, right, the way they do it is using TTPs. They standardize these crimes, right? This targeting. And the fact that he's the best paid lawyer in this group with this, I'm talking about the payments from the Communist Party of China. I think, you know, this requires a serious investigation, right, by authorities to see in what why is he being paid, you know, 2 orders of magnitude than the median of these lawyers. There has to be a reason, right? The payments have to correlate with something. The question is, what is that something, right? And this is important because it may lead to identifying other children being targeted, right? I'm guessing that mine is not the only child being targeted by the Communist Party of China. And this could be a lead to find more. Okay. Yes. So this is a short comment about, I implemented some kind of a short link feature in the website. So if you go to yes, so if you go to the spyhellfiles.com/Adams, it will take you to the first demo, the first Codelab, right? Also, you can do it by the demo number. So you can do, for example, the spyhellfiles.com/91- for example, 3. That will take you to the third video of the demo series 91, right? So I just wanted to, you know, to document that this feature exists because it's not documented anywhere. But it may help for people that want to understand how this network operates to control the planet. This may help people sharing, you know, the videos. Now, I also want to ask a favor. I don't know if anybody out there has, you know, influence over Amazon. Let me tell you the problem I'm trying to solve, right? Or that I would like to solve if I could. I would like to put that link, the spyhell.com, spyhellfiles.com/Adams, as an image in the cover of the book, because I mean, I think that demo is fundamentally important because it will show people how to find, you know, actors in this network using BigQuery. So I would like to put it in the image, right, on the, like, in the cover of the book. Like, so if you go to the book, you go to Amazon.com, right, and you search for RJ IPR IRS, right? What I would like to do is to put that URL in this cover, right? But I've had problems in the past with Amazon because every time I put a URL in the cover, somehow, like, they start like flagging the book and then they don't publish the book. Like, it creates an excuse for them to take the book out of circulation, right? And I know that that's something that the network is doing, right? Like, they're targeting these books, and anything that they can find to get them out of circulation, they will do it. So that's why I haven't done it. But I would like to try to do it, because if I can put that in the cover, that it's an easy way to share the information across the planet, right? Everybody can understand that this is a URL, right? So I would like to put in there the spyhellfiles.com/Adams, and that will take everybody to that demo of BigQuery, the BigQuery Codelab, right? So I guess the favor is, if anybody watches this and knows somebody in Amazon that could, you know, help get approval for this, you know, please help me out. Okay, next item I have is let's see. Next item I have is about, yeah. So in the last demo, right, there was a metric that I computed that was the number of days that the case was open. And a part of that, I've noticed that one of my cases had a note created that said rehearing, notice of rehearing due, or something like that, right? And when I saw that, I thought, well, this could be the deceptive title TTP again, right? Because this is what Morgan Heidner did with the notice of entry temporary orders, right? That got the case dismissed in this court. So my immediate reaction was to think that this could have been the TTP. But then I went and looked at the cases, and it seems like all the cases have this thing. So this is something that automatically happens. It's a deadline, I think, right? I don't know. I have to run the legal vaccine to understand this better. But it seems like this is a procedural thing that happens in every case, which is fine, right? So it's not, they're not trying to hoard my Supreme Court case with this. But this means that all these cases in this metric that says, number of days open, like that metric is shifted by 15 days, right? Because all the cases will have this event 15 days after they were closed. So this number, 146, is not really 146. We have to subtract 15 from that number. But this makes it worse because my cases, right, were open for something like 17 days, right? And the two cases I have, the average is 17 days, but we have to subtract 15. So it means that in reality, my cases are just open for a couple of days, right? Because this metric is being inflated by 15, right? So the numbers I reported in the previous demo are not real. I mean, we have to correct them. And the situation is much worse than it looks if you look at this metric, right? It's obvious that my cases are procedurally closed very quickly without a hearing in the First Court of Appeals in a matter of 2 or 3 days, while all the other cases last 6 months, and especially the cases of these attorneys, right? So that shows that this court is, is targeting my cases, right, specifically. And it's a statistical analysis, right? It's not an opinion. You can see these are hard numbers, right? That it cannot be, disputed. Okay, so next, for my next trick, I want to do a little bit of work with you here on ranking. Okay, let's work on metrics that we can derive from this data set that is already built, that I'm showing you here, right? And we can derive interesting metrics that at this point I've reverse engineered that I know that they use, right? And I'll tell you that in a second. Okay, so the first thing that we're going to do is that we're going to go to BigQuery, okay? And we're going to write some queries to derive metrics that we're going to use to rank these attorneys by different criteria, so we can see different things. So you can click on data sets. And this is the data set we were working on last time, right? It's called Adams_first_court_appeals_Texas_CJ, as in Chief Justice_Adams_US_Central. And we're going to concentrate on this table that is joined with the crypto payments, okay? Let's work on that one. Okay. So, okay, so let's start by, I want to increase the size of this a little bit. Okay. And we're going to start working on a query, okay? So the idea here, right? So this is when you did, well, and now I'm going to go, into the technical part. What you want to do when you do ranking of these things, like, so we already did retrieval, right? So we know that out of the 2,500 rows, there are 92 rows that are attorneys that are important, right? And I mean, are important because they're marked in the index, like they're part of the network for sure. And we're seeing the score, and that score, like if you think about it, that score that we're ranking them by in that table is like the equivalent to NAV boost at Google, right? In that boost, they have a signal that is similar to that, but with clicks. But what we're doing here is replacing the clicks by crypto payments. So this is a very good signal to do retrieval and lightweight scoring and ranking. But we can do more sophisticated things. So the idea is we can parse the metadata that we have. We have the addresses, we have the phone numbers, we have the names, right? So we can find name markers, matches, right, in those things. But so the idea is you first, this is a multi-step process, right? And this is pretty much a standard everywhere. So the first thing you have to do is to normalize the data, right? Because you could have things like, Adams written in uppercase, if it's the Adams law firm, or in, camel case, or, you know, you could have a comma that could break a match. You could have a dot. So what you have to do is to normalize all these things so all the text looks similar, right? So it's standardized. And then you move on to find matches. So the first step is normalize. The second step is hit counting. So you have to find the hits. You have to find where the things that you're looking for exist in this metadata. And that is called hit counting. You keep a counter. How many times you find the token Adams? How many times you find 00? How many times you find wood, right? In the name, in the address, in the company name, in the firm name, in the how many times you find 00 in the address, in the suite number, in the phone number, right? Like all these things, you count them. And then you do something with the counts, right? You combine them with a mathematical formula. That is called scoring, which is the third step. You take all these numbers and you combine them in some way, right? And you can play with different versions of scoring, different functions. And the last step is ranking, which means after you score them, you sort them by decreasing score, right? And that's how it's 4 stages, right? So we're gonna do the 4 stages here. So the first one is normalizing, right? So the first thing I need to do is to understand the schema, right? So you can see here in this list the things that I have, right? So the things where I can get hits from are honorific prefix, given name, family name, honorific suffix, the law firm, the address, and the phone number. Right? From all those things, I could derive hits. Right? I could find hits in those fields, but I need to normalize them. Right? So the first thing I'm going to do is to write a way to normalize them. So because we're going to do BigQuery queries, I could do this inside of the query, but this will make it so that I would have to be repeating these statements in BigQuery many times. But there is an easier way. You can write a function that has this logic, and then you can call that function, right? So the first thing I'm going to do, I'm going to go to this Gemini thing, and I'm going to ask it to write a BigQuery function that I can use that normalizes the text, right? So that normalizes a field of text in the following way. Okay, 1, it makes it lowercase. 2, replaces all punctuation and special characters by a space. So if there's a special character, I'm going to put a space in lieu of that special character. But that will make it so that after I do that, there might be multiple spaces, right, in a sentence. So I need then to remove the multiple spaces and replace them by a single space. And the sequence here is important, right? Okay. Let me think what else can I do here. Yeah, I think that will probably be enough. If we need something, if we see a problem, we'll fix it after, okay? Okay, so I'm going to create that function, and that function is going to be recorded after I create it, it's going to be recorded in the data set. I mean, I don't have to do this again, right? It's going to be saved because I'm using here the create or replace function. Right? Let me see. Oh, because it's yeah, I need to put the data set and then. No, let me see. Maybe without the project name. Yes. Okay, the error was that I was including the project name into the name of the data set. For this, you only need to put the name of the data set, not the project name. So now I can see the function, right? Okay. Okay, I don't know. I'm tempted to test it, right? So um, the function is called normalize text. Okay. So I'm gonna see if it works, right? Select normalize text. I think maybe I need to also, when I call it, I need to do this. Yes, so you see it works, right? So I put a bunch of special characters and an R in the middle of them, and it removes all the special characters, and the R is there in lowercase in the middle, and there's no multiple spaces one next to the other, right? So it worked perfectly. So now we have a function that allows us to normalize the fields, and to call it, we have to basically call this function, normalize text. Okay. So if we go back to our query, right, that we're making, let's start by normalizing, just to see if this works here, normalizing the address. Okay. Where normalized address is not null. And we're going to order it, to sort them, order by what is the field with the score? Yes, this one. Okay, this is I'll explain why this happened, this bug, right? This error is because I'm creating a field, right, with an alias, and then I'm referring to the field in the same query. I can't do that. I have to wrap the query inside of another select, and then I can select like that. So the solution to that is I can do select all from, and then I wrap the query that I have. And I think I need to put the dataset name before the function, as we saw before. Okay, and because I need to also include that field in my select, so I can have access to that field. Okay. Okay, so here you see it, right? All the addresses are normalized, and I'm sorting them by score, right? Now, one thing that I forgot to mention, that I saw this already in the previous demo, right? I mean, I saw it, and I was going to mention it, but I forgot. There is an address which is 600 Travis in this data set, that it's a building where multiple of these firms that are marked have an office. And this is another level of aggregation, you see? Because like if you look at the addresses individually, they will not match because they have different suite numbers, right? They're in different offices within the building, but all of them are in the same building, right? So the building is an aggregator. So what you can do is you can aggregate by the building without the street, without the suite number. If you do that, you will see that there's multiple law firms in which the attorneys are marked in the index, that have offices in this 600 Travis building, right? And they're all working with the Adams, law, um, that version of the law, right? And they should be here. It's interesting that they're not here. Oh, because I'm only seeing, I don't know. Let's I don't know what in this where, right? I could add the condition that contains 600. I don't know, to see if we find it. Right? So I'm gonna only match the ones that, sorry, only the ones that, sorry, this UI sometimes is a bit tricky to work with, but right. So you see here, right, how many they are. There are 16, right? Different rows that have been smeared in the way that I described before, that have different suite numbers, right? So there's a firm in the 2800, there's another one in the 7000, another one in the 7500, and another one in the 5600. But you see, like, they're in the same building, and the number of zeros give you an idea of their prominence, because this is a marker that they have, right? So how many zeros, consecutive zeros, are in the full address? It's a marker. So for example, this one has, sorry, the one that has the 7000, right? So this is the most prominent one, because they have two zeros in the street number 600, right? It has two zeros together, and then they have three zeros together on the suite number, right? So this one has five zeros. These, among all the firms at 600 Travis, these are the ones that are the most prominent, right? I can bet you that. And when I tell you these things, is because, well, because I have the data. This database is kind of a Rosetta Stone, right? By doing machine learning on the scores of the people involved in, for example, in the firm, right? They individually, they have their scores, right, in their homes, in other things, right, that I can find in public records. Then I can do machine learning on what is the correlation, to find correlation between the number of markers, right, potential markers. So my system finds candidate markers. 00 could be a marker. So it does an analysis to see if there is positive correlation between the number of zeros and the aggregate scores recorded for the people involved with that specific firm, right? When it finds the statistical significant correlation, it means that this is a marker, right? That's how I find the marker. So that's how I reverse engineer the encoding system that they have, right? And based on that, I can tell you that 00 is a marker. That is in the license plates, is in the phone numbers, is in the street addresses. So what I think they do, and I cannot prove this because I haven't seen the app, right? I mean, I have seen it, but I haven't had it in my hand to use it, right? I have photos. I've taken photos of the app that the agents use, and they are in the archive. But I haven't had a chance to play with the app myself, right? So what they do is that they have systematized this into an app that gives the user kind of a trust score, right? So imagine that they take a picture with the camera, or show a document to the camera, and the document looks at who sent the letter, what is the address, what is the phone number, right? And computes the hits in the same way that I'm going to do here in BigQuery, and comes up with a trust score or a clearance level, right? Then that way, the person that has the app knows, okay, I know that this person is an agent. The person doesn't have to know where the markers are, right? This is systematized. And this is how they scale espionage to planetary scale. Because now they don't have to train the agents. All they have to do is encode this knowledge of the markers in the app, right? But the problem is that they gave me the database. And because I have the database and I have the know-how on how to reverse engineer what they did, that's exactly what I did, right? And now all this is public, right? But anyhow, just wanted to show you the 600 Travis example, especially the 7,000 suite, right? And actually, let's look at the firm, right? What is the firm in that? So here, you can select from this thing, the firm, the law firm. And this is interesting, right? So in that suite, 7500 at 600 Traverse, there's two law firms at least, right? You can see here that McCool, right? And this is the thing, like they give these funny names to things. Like I don't. That's something I haven't been able to understand, right? Like when they name people like the Aaron Kool-Aid, right? Like the the or this McCool, right? I don't know. Like I don't know really what to make of that. But they do. That's the thing, right? They give these funny names to important people. Um, so there's that one. Oh no, sorry, it's not that one. It's different, right? So this is 7,000, right? So this is the important one. McCool Smith PC. The one that is repeated. Ah no, it's not repeated. It's sorry, I misspoke. It's not two firms. I misread. Uh, yes, there seems to be only one firm per row. Let's check if that's the case. 52, 56. Yes, yes, they're unique to the suite, right? So I misspoke on that. But the most prominent one is this McCool Smith PC within this 600 Travis building, right? But this is another example, right? What are the chances that all these law firms and all these attorneys, really, because remember, like the match is from the attorney's address that they personally gave to the bar, right? Not necessarily the firm. What are the chances that all these attorneys are flagged, right? Are marked in the index? I don't know. And they all are in these different suite numbers, right? In the same building, right? Go figure. But okay, well, but the important thing is now we have a normalization function that we know it works, right? Because we're testing it here, we see that everything is normalized, right? Now let's move on to hit counting, okay? For hit counting, what we're going to do is we're going to do the same thing. We're going to ask Gemini to give us a function, to produce a function that we can create that counts the number of occurrences of a substring within a field, right? And then we're going to use that with the normalize function. So this function we're going to create is going to first normalize the field, normalize the text that it's receiving as an input to match, and then it's going to count the number of occurrences of the normalized text to match in the normalized field, right? That's the key. Normalize everything and then match. So let's do that, okay? So we're going to ask create a big query function that does this. One, accepts a field name and a string as inputs. Two, normalizes the field received as input using the normalization function produced before. Three, normalizes the text received as input. Four, counts the number of matches of the input text normalized on the input field normalized. Okay, this is more complicated query, right? Let's try if it. Let's see if it works. I don't know. I just saw it like very quickly, and I think it has a bug, but I'm not sure. Let's try. Okay, so let's do the same. Let's create the function, and we know we have to change the data set, right? We have to put the data set in the function name. And here, and here. Let me see. Okay, let's ask, because it's a complicated query, right? So instead of, I'm not going to debug it yet. I'm going to ask Gemini to see if it can spot the error. Okay. Yeah, I think this is the error that I saw intuitively, right? Yeah, this sounds better. Let's see. Oh, let me see. Let's try again. If not, I'll do it by hand in the query, right? But let's give it a chance. Let's see. Yeah, I think it's using legacy. Yeah, it's using legacy, see? Yeah, I know this part is complicated, right? But hopefully we'll get to something that works. Okay, now we're getting to some. Now it's producing a number, right? But the number is in the incorrect. It's not a. It's not a. It returns an int, but it's expecting. It produces a float, right? So it's just a question of the type not matching. So this, it means that we're almost there, right? Yeah. Aha. Now we have something, right? Okay. Okay. So this is the actual function, right? I want to save it. Field content. Okay. Okay. It's saved. Okay. So now let me show you the power of this, right? Now we can go back to our query where we were working on before, right? So again, like what I'm doing here is really like beyond the debugging this code, right? What I'm doing here is giving you a repeatable process, right? That like a repeatable process that you can apply quickly and solve this at scale, right? So right now we have this. Uh, let me add the other score. Let me remove this. Okay. Okay, so now let's format the query, right? Because it's getting a little bit ugly. So you can click on these three dots over here and then click on more and then format, right? And that will format the query so it's more workable. So what I'm going to do is after the address, I'm going to start adding my hit counters, okay? So I'm going to add a hit counter for the bigram. And you know what the bigrams are, this is discussed in the box, but it's really a join of two characters. In reality, from information retrieval, it could be two words, right? It doesn't have to be characters. But in the context that they use it, they use the characters as if they were unigrams. So when you put two unigrams together, the fact that they're together, that forms a bigram. And that is an important signal for their system, right? About prominence and level of clearance and things like that. So I'm going to find, let me see the function signature again, because I can't recall what it was. So the first argument is going to be, what is it? Okay. The first argument is the field, and the second argument is the text we're searching for, okay? Okay, so the first argument is the field. So we're gonna search in the address. Actually, let's do this better, because there's a problem, right? So there's two addresses. There's the address of the lawyer, and then there's the address of the, actually, we have to fix the function, because there's two addresses, right? So there's the address of the law firm and the address of the attorney, right? And you see, the two are important because you could have matches. I don't want to pick one or the other because you could have matches on the two, right? It's possible that the attorney has a bigram 00 in his personal address that he has with the bar, and that the firm as well, right? So I want to count them all. But it is also possible that one of the fields is null, right? Doesn't exist. Like for example, in the case of Branson, I think this is Branson. Chris Branson, right? His address is 2499, right? But that is the address of him with the bar. But he doesn't have a firm address. Like his law firm, which is his own personal company, because I looked it up in Google, doesn't have an address, right? In Google, it just says Houston, Texas, because he's secret, right? He's a secret agent. So these are supposed to be secret. So the address is not in Google. I'm talking about the company that he has that operates as a law firm that I think has his name on it. But anyhow, so I want to count them all, and this will create a problem in the function we just created, because if the field is null, the result is going to be null. So I can't allow that. I have to default to 0, right? So I'm going to say to Gemini, modify this function so it defaults to 0 if the input field is null. Right? And then I'm going to have to rewrite the function again, right? I mean, in the data set. So I'm going to do that now. Okay, it worked. Okay, so going back to our function, right? And this function, this query, I'm gonna save it in this other set. I'm gonna save it so we have it for later, right? So I'm gonna save this query as hit counting. Hit counting. Okay. So so I'm gonna count the number of zeros in the field address. It's obviously not working, right? Because it's not address, it's normalized address. Let me see. Okay, so what I'm gonna do, I'm gonna move this one level above, right? And I'm gonna call it normalized address. Yeah, it's not working, I think, because this, for example, has 3 zeros, right? It should have matched. It should have matched 1 time here, 2 times here, and 3 times here. So it should have 3 bigram matches on the double zero, but it's not. It's not working. So let's go back to Gemini and ask. There seems to be a bug, for example, a field with value produced 0 for this. Oh, okay, I have them in the opposite order. It seems. I don't know. I thought I saw the signature. Maybe I made a mistake. I don't know. It's possible. Let's invert. So supposedly, according to Gemini, the problem is that I have the fields inverted in the signature. Wow. Yeah, it's true. See, for example, you see this 2200, right? So it has 1 match here and it has another match here, and you see the number of hits that it got is 2, right? Perfect. So now we can count them. So this is a nuclear weapon because now we can identify all these things, right? Okay. So now I'm going to do the same, but with the other field, which is the so this is the address, and the other one is the law firm address, I think it's called. Firm address from places API. Yes. So I'm going to normalize that too, okay? Right. I'm going to normalize. Instead of address, I'm going to say firm address from places API, okay? And this is going to be normalized firm address, right? And I'm going to count the hits on that. I'm sorry. Normalize firm address. I'm missing a comma here. No, sorry. Here, okay. Okay, so now I'm counting the 0 zeros, right? So you see, for example, this one has it on the address of the lawyer, but this one has it on the address of the firm. And here there's a beautiful example that has it in both, right? So this has to be this is a prominent attorney in a prominent firm, right? This is even better. Um, and this is Catherine Nechman. Is the firm, right? But I want to understand who's the representative as well, right? So I have to add the representative. Okay. It got it because she registered. So that's not a good example. She registered her own address with the bar as the firm address. It's the same. That's so she got it twice, right? But I'm trying to see if I can find one who has two addresses that are different and has the two hits, like this one, right? Yes. So you see this person, right? He has two different addresses. I'm saying he. I don't know. No, it's a lady. It's a Tiffany Rausch. So she has two different addresses, right? One is 811 Main Street with the suite 2900, and that's where she has the hit, right? And the other address she has is the firm address at 1401 McKinney Street, suite 1900, and that's where she has the other hit. So she got the two hits, and the two addresses are not the same, right? So this is a prominent person, right? But you see, so we can count the hits now, right? And we can do this with things that are not numbers. For example, counting in the addresses the word Adams or the word Woods, right? Right. And I think here I'm going to improve the function a little bit, right? I don't know if I can do this. Let me see. Okay, let's try to improve it. What I'm thinking is to modify this function so I can count among a list of possibilities, right? Because right now it's counting one string, 00, right? Or I can pass one string at a time. But what I would like to do is to be able to pass a series of a string in a single argument. Like, for example, Woods, Adams, what's the other one? Shadow, right? Like, all these name markers that they use, pass them all as a comma separated list of words that I can then, and that the function finds them all, right, at once. So that would be the ideal scenario, right? So now modify this function to accept, instead of a single string of text, a comma separated list of strings, like Adams, Wood, Shadow, Hunt. Okay. Yeah, this is what I want, the inline method, right? Yeah, let's see if this works. I don't know. I don't know if this is going to work. Because it makes this much more complex, right? But let's try. Okay. Okay. Now I'm going to try to count. Okay, let me see. Oh, it says not found. 1 second. Let me see. Oh, okay, I made a mistake. Okay, let's see if it works. Yes. So, for example, this one has a name hit, right, on those important markers. So, for example, Joshua Sandler, because the street name is Hardwood, right? So you see the wood matched there, right? So that is also a signal that this is a prominent person, right? This is and this was in the address of the attorney, right? So you see, now we have numeric metrics that are related to different type of matches in different type of things, right? And we can do the same with the phone number, right? I forgot to tell you about that. The phone number hits. You will see that all these firms have 00 in the number, right? Which is also a statistical anomaly in itself. Because, I mean, not that they have the 00, but what are the chances that all of them are marked in the index, have the crypto payments, and also their phone numbers have the 00, which is a prominence marker, right? That this network uses everywhere. It's too many coincidences. So we can also add the phone number as a field here, right? We're going to normalize that text. And here we're going to say phone number. Phone is called in this data set. Right? Okay. And then we're going to count the hits for 00, okay, in the phone number. I'm going to call that normalized phone number hits, okay? I'm going to remove the normalized prefix to make it shorter, to make the name shorter, like to make them more like this, like address, name hits, right? Address, 00 hits. Firm address, 00 hits. Phone number, 00 hits, right? And the other one is the name of the attorney, because the attorney could be called something Wood, right? Like that Wood in the name is a marker, or Adams, or Hunt, right? All these are name markers. And when I say this, I'm not saying this because I've interacted with these attorneys in the context of my case. I say this because before interacting with them, I had identified that these were name markers by reverse engineering the encoders that they have using the scores in the database that the Venezuelan intelligence handed to me in 2024, right? So I already knew that these are name markers. So when I encountered the Adams law firm in April, I already knew what was coming, right? Because I know that this is a name marker. Anyhow, but we can also count the hits on the names, right? So I'm going to add the name. Well, I already have it, the representative, right? And King is the other one, right? King. Okay. And we have to do it in the parties as well, because the party could be in collusion with the system, right? To get a payment for settlement, for example, right? That's a way to funnel money from one entity to another without paying taxes. And I've discussed this in the book before. So I'm going to do the representative hits for the right, representative name hits and the party as well, right? Mm. I'm just normalizing them, right? Although this is not necessary because the function also normalizes them, but just to be consistent. Okay. All right. So now we're counting, and like we can extend these, extending the list of the name markers, right? But I'm just going to keep it simple here. But you could, I have a dashboard that has the name markers. You can see it here. If you go to spyhell.org, I think it's in there. I can't recall, to be honest. No, maybe in evidence. Yeah, in one of these dashboards, I can't recall which one, but one of these dashboards in this page, which are these links over here, contain the markers. I have the list of markers that, I mean, it's not a complete list, but it has like, I don't know, like 50 markers, right? That could be interesting for law enforcement. Okay, so I'm gonna do that again, right? And now you're gonna see. Oh, and the other markers you have to check is like the third, like Robert Mueller the third, right? That third is a marker. Oscar Telfair the third, that third is a marker, right? The junior is a marker, right? The judges that you see that have junior in the names, those judges are marked, right? So let's add those, right? So let's add junior, the third, the fourth, right? Okay. And I'm gonna save my query. Okay, so now you see, for example, this person, right, has an address name hit. Now let's see if we find a representative. Yeah, so there's a party name hit on this one, for example, right? So you see how easy it is to catch this, right? Now that you have the coding ring and you have the technology to count the hits, because you have this in BigQuery, right? It's trivial. It's trivial to catch them. So this party, what is the name hit? It says party name hit. It's either matching junior, 3, 4, Adams, Wood, or Hunt, or King. Party name hit. What is it? I don't see it. Oh, it matched the 4 individually. So yeah, this we have to correct, right? Okay, one way to so the reason why it matched is because this string IV is too short, right? And it could match a word that has those two letters together. One solution is to put in a space before, right? To forcing a space. Let's see if it works before these denominations, right? Right. So this would mean that it would have to start with. In fact, you can make it even better, right? You can say a space before and a space after, right? It means that you need to find the entire word, basically. Right? So here I'm playing with how I'm encoding the parameter, basically, to not have to modify the function logic. Because I could also fix the logic, right? To avoid this bug from happening, which is the better solution, right? But we're gonna do it here. So let's see if we find a party name hit. Okay, so there's a party name here. And this party, see, it has the JR, right? So JR is there in there, right? So this party being called JRPN, right? This JR is a marker, right? So that party could be part of the network, right? So we have to look at the address. I mean, this is a signal, right? You don't have to, you cannot trust one signal only. You have to combine the signals. But so if multiple signals are telling you this is an agent, it's probably an agent, right? And then you have to weight these signals by multiplicators, right? You have to give different weights to different things. So for example, I would give more weight to the 0, 0, right? So I would make a multiplier that says, a match on the 0, 0 is worth 5 times, something like that. A match on the name, right? We have to come up with different weights, but you do this with machine learning, right? You test different algorithms using machine learning to see how you find better correlation between your mathematical formula, your scorer, with the scores in the UA index, right? That's how you align it, and that's how you calibrate your scorer, by using machine learning to find correlation, right? What you want to do is to align your scorer so it follows the scores that are represented in the database with the crypto payments. The logic is the people that get paid more are people that are, probably are doing more criminal things, right? So you want your scorer to understand that, to follow that logic, right? And you do that by tweaking the weights on how you multiply these scores. But right now we're just counting the hits. The next step is to create a formula to rank them, right? And we're going to experiment with different formulas, and that's going to be the end of the Codelab. But we can count the hits, right? But an interesting question would be, what is the address of this party, JRPN? Oh, I see. So the child is marked. Imagine that. Wow, this is interesting because he represents children, right? I mean, this Chris Branson, who has 32 million points in the crypto payments. And the children, and I know this because I went through this process, right? The children cannot appear in these public dockets with their names because, the courts protect the children, right? Supposedly. So they abbreviate the name, right? So these JR are the initials of the child, right? So it is possible that they mark the child, right, with these initials. Because, I mean, they pick a name that started with J, and the middle name started with R, or the last name, right? So when you abbreviate it, the child results the abbreviation in JR, which is a marker, right? This is serious because this means that they're marking the child. I mean, if this turns out to be the case, right? If you look at the address of the mother or the father, whoever is getting the child, right? The one that is getting the child is probably the agent, right? They're gonna coerce the other one. So the one that gets the child is the agent. So if you look at the address of the mother of this child whose initials are JR, and the mother is marking the index with crypto payments, and the lawyer representing her is marking the index with these 32 million crypto points in crypto payments, you know, you can put two and two together. You know what happened, right? So they did the same to this person, right? So this is interesting. But you see, this is the kind of thing that a human will not, I mean, I would have not seen this. Like, you have to use technology to find these things because this is a planetary scale operation, right? So you need technology to detect it in the way that I'm doing here. So, you know, I think by just looking at this, right, that this Carson person, what is the name? Branson, right? This Branson person that has the highest score and is concentrated on the children, and there's a children that seems to be marked on the name, right? I mean, with this, I'm happy. I'm seeing that I'm on the right path. Like, I can tell you that right now, right? Because this child could have fallen into any other attorney, but it fall precisely on this one, right? And you can see these numbers, you can also aggregate across cases. So an interesting metric would be what would be the aggregated score of Branson across all his cases. Some cases will have the name marker, some cases will have the street marker, some cases will have, I mean, some parties will have the phone number marker. Some parties, you know, if you aggregate across the attorney, see if the aggregation point being the attorney, across the hits gathered from the parties that he represented or that he litigated against. Those are two interesting metrics that you can use to compute a score for the attorney, right? So your goal here is to aggregate on an aggregation level that allows you to smear signals. That's what I'm doing, right? Smearing signals from the street address, from the phone number of the party, of the firm, of the attorney, right? Smearing signals to the attorney, smearing signals to the case, smearing signals to Chief Adams, smearing signals to the court, and then you can do comparisons across courts, right? Across the chief justices of different courts, across different courts, aggregated, right? By counting the hits on the cases and the parties and the attorneys and the lawyers, right? This is the reason why they can't escape this type of detection, because it leaves a signature that is detectable by statistics. Like, these are anomalies, right? And they can't hide them, because the fact that they're using an encoder to make these procedural decisions and to make this industrialized process of deception and malfeasance leaves these statistical anomalies, right? That are a direct consequence of what they're doing. So therefore, they can't hide this, right? And this is the weakness that we need to exploit, the aggregators, right? So, you know, I'm happy with proving that the concept, right? When you can expand this by expanding the hits, like you know, if you're looking for 06 in the phone numbers, those are intelligence officers, right? If you're looking for 00, these are key players, right? Like these people. The same with the addresses, right? Like, there's different numbers in the street numbers of the address that signify different things. But, you know, I think this, for a proof of concept, which is what I want to do in this demo, I think this is more than sufficient, okay? So what I'm going to do next, right, I'm going to restrict this table by the ones that have a score that is positive. Right, so we work only on the 92. This is giving me 136 for some reason. Because there's attorneys that appear multiple times. Like, for example, this Chris Branson, right? You see, there's 4 rows with his name, but he's only one person, right? The only thing I'm going to do, I'm going to add the case number, because I want to be able to aggregate by case. I want to be able to aggregate by attorney. And of course, the next step is to also aggregate by justice, right? Who was the justice or the quorum that made the decision in this particular case, right? And smear the signals to the judges, right? To the court, they call it per quorum, I think, right? When it's a panel of 3 judges, for example, right? It has a different name. So you can fingerprint the panel by the names of the judges that were part of the panel, right? So you fingerprint that panel, and then you smear the signals to the panel, and you smear the signals to the individual judges, right? And then you do this aggregation across the hits counted and gathered across all the cases for each judge, right? And then you rank the judges, right? That's the key. So the idea is combining the gathering of the hits with aggregation and then scoring and then ranking. Right? And then you can rank anything. You can rank the courts, you can rank the judges, you can rank the panels, you can rank the cases, you can rank the attorneys, you can rank the firms, you can rank the parties. Right? You can rank everything. And then you can understand who are the top players in each dimension, right? Because what is happening is collusion of different actors, right? Judges colluding with attorneys, colluding with the parties, right? To move money around or to do different things. So you need to rank them individually, right? And then, find cases in which multiple top players are acting in the same case, right? And that is the smoking gun. Like, that's something that they can't escape. So I'm going to save this as a table. I'm going to put it in the same data set. And I'm going to call it, I'm going to give it a name that is similar to what it has. And I should have copied the name. What is it? Okay. This is the name. So I'm going to save it in BigQuery. I'm going to put it as a prefix here. Okay. I'm going to call it the first court of appeal, hit counter, and then the rest. I put it at the beginning so it's easy to see in Data Studio, because remember, the names if are too long, they get truncated, and then it's hard to distinguish which table is which one, and then you can get confused. So in this part, I'm going to go to Manage Added Data Sources, and I'm going to add that data source by clicking on BigQuery, then on the project, then on the first court of appeals that says US Central, and then the one that says hit counter. So it's this one over here, right? Okay. So then what I'm going to do, I'm going to start playing with this thing, right? So let me show you this trick. This is something I really like about Data Studio. You can go to Manage Added Data Sources, and you can click on the data source that, for example, in this case, the hit counter, right? And you can create new fields in a pseudo language that Data Studio has. And you do that by, let me see if I can, this one, add a field, right? Add a calculated field. And then here you can write a formula. This is not really SQL. This is more like a proprietary pseudo language that Data Studio has. I mean, Google developed for them, right? But you can write formulas here. So I can say things like, for example, I want to create a score. I'm going to call this my score V1. Okay. And then I'm going to start iterating on different ideas, right? So I want to say, I have to remember the names. This is the tricky part, right? The names that I gave to the different hits, right? The counters. So address, name, hits. So the logic here, right? I mean, I'm going to start by creating a version of this, right? I'm going to create a mathematical formula that represents with a single number the prominence of a person based on these hits and the scores in the index, right? And the number of cases, things like that, right? The idea being, I mean, when you think about how to score things, try to think, in these cases, right, for this network, try to think on the things that don't change easily. And this is something that Google applies everywhere, right? Like, think about a web page, right? The title in the web page, or what the web page says, is a signal, but it's not a strong signal, because the webmaster can change that. Anybody can put anything they want on the title, and then they could trick the algorithm, right? So they don't trust that very much. They trust things that you cannot change easily, right? For example, the address in the credit card that you use to register the domain, right? Because that you can change that quickly. I mean, you do that action once in your life. So what that address is could be important, right? Just giving you an example. So, what is the things that they can change is, for example, the name of the lawyer, they can change it because it's registered with the bar. It's in the passport, in the driver's license. It's in many places, right? It's in the website. It's reputation. It's tied to the reputation of the lawyer or of the judge. So they can change the name. So I would give the name markers a high weight, right, in this initial version. So in Data Studio, right, I can say that this score B1 is going to be 10 times the number of hits in the name of, sorry, not the address. The address, they can change it in Google Maps, right? I'm talking about the name of the representative name, right? This one. Or the party name hits. Sorry. I'm going to give it two different weights, right? Because the party name could change because they could, they could put anybody to be a party in a lawsuit, right? That is easier to change. You can change the party, right? It's easier to change than changing the name of the attorney or the name of the judge, right? So that I'm going to give it a weight of 2, right? But it's still more difficult to change the name of a person than to change an address in Google Maps, right? Okay. So because of that, address name hits, I'm going to give it a weight of 1 because they can easily change that in Google Maps, right? And I'm going to also give it a weight of 1 to the address of the firm, right? Firm. No, what is the name? Firm address. I didn't compute it, it seems. Let me see. Address name hits, representative name hits. Yes, I didn't do it. Well, I did it for the zeros. Okay, I should do it. Let me do it. To do it the best we can, right? So this one is going to count, instead of counting in normalized address, it's going to count in firm address from Places API, which I think I had normalized here. Yes, normalized firm address. Okay. Let me see something here. Okay. I can just override the table by doing this. Create or replace table. And you need to add the data set and everything. Okay. So this will replace that table, but then I have to refresh it. If you do this, that after you create the connection in Data Studio, you need to go, if you replace the table, change it, you have to go and refresh the Data Studio data source to get the new data. Okay. So I'll do that, right? So for now, I'm not going to modify this too much. I'm going to save the field. And the field is called score v1, okay? I'm going to click done here. And I'm going to edit the field. And then there is this button here that says refresh fields. It's at the bottom. When I click that, see, there is a new field that is the firm address name hits, which is the one that I just created in BigQuery. So I'm going to, apply it so it gets ingested. And I'm going to search for my score v1 field so I can edit it and add that, right? So what I want to do is to really add the firm name address hits, but I'm going to give it a weight of 5. Right? Because the firm, they can also change the firm. They can create a new firm, right? It's not that difficult, but it's more difficult to create a new person, a new judge. Like how, it takes decades, right, to get a judge into those positions. Because they have to go to law school, they have to pass the bar, they have to get appointed. It takes a decade at least, right? So I'm going to add my score here, right? Okay. And now this is the nuclear weapon, right? Because now you can do this. You can create, for example, a table, right? So I'm going to create a table to aggregate by attorney, right? So all I have to do is create a table. And here I'm going to say representative. And the metric is going to be the score. Right? So if you do this, well, this is just by looking at the hits, but you can, okay, so this is V1, okay? Now let's make V2. V2 is the same. This one, right? Field counter, right? Let's find V1 first. We can copy the formula. Okay. So that V1 really is not a score. I would say it's a trust score, right? That is more equivalent to a trust score, because if you have all these markers, that gives you certain level of clearance, right? But that's not, you cannot only look at the trust, because somebody could be trusted, but maybe they did not commit very serious criminal acts. But if they have the crypto payments, if they have the trust, so it's the combination of the trust and the crypto payments, really what it should be the score. But this, let's rename it. It's not really a score, it's a trust score. Let's call it that way. Okay. I mean, trust is confusing because it sounds like they're good people. I mean, they're good actors, right? I mean, trusted by the network, right? So let's call it clearance score. So there's no doubt that this is something criminal, right? Clearance, in fact, I'll call it network clearance score, right? Okay. Okay, done. Okay. So now look at what I'm going to do. So you have now the network clearance score, right? And the representative, right? The representative is the attorney, basically, okay? Now, I'm going to add another metric that is the crypto payments, right? And I'm going to add another one, which is, and this is another thing I wanted to show you. You can create a new calculated field in this table only, not in the data source, but in the table. So I'm going to say this is the score V1. And it's going to be the network clearance score multiplied by the crypto payments. Sorry. right? And this, the pivot, the aggregation point is the lawyer, right? So if you sort by the score, B1, surprise, surprise, who comes on top is still Chris Branson. And now the difference is not, I mean, this is interesting, right? So even though I added all this complicated logic with the weight, the hit counters and all that, the distribution is still Chris Branson is the first and Andres Soto is the second. Probably because the crypto payment difference is so high with the others that they're still Trump, right? The entire distribution. But this is just one example, right? So this would be, let's name this, right? So this would be a score V1 for attorneys, right? Now we can just copy that idea. Sorry. Okay, and here, instead of the record count, we're gonna rank by that, by score V1, right? We have to also add the calculated field here. Oh, the data source is wrong. Hit counter. Right. And this would be what? This will be score. No, I'm gonna create a new metric here. Score V1, and this would be the network clearance score multiplied by the crypto payments, right? Just so I can see it in the map. Right? And the location will be the address. Okay. This is because I have to remember what I told you in the last demo. You have to mark that field, normalize address. You have to mark that field as geo. The same with the normalized firm address, right? Okay. Right. So there you can see, right, what the focus of this is. So this is good. And the table, I'm going to sort it by the score. You can do that here in the sort by the score V1, right? Now, in the hit counter, I think we can do better because there's a field that is important that I did not add, that I should have added, which is the 00 hits in the phone number and in the addresses. I mean, that's the more one of the more important, this address 00 hits, right? That's one of the more important markers, right? And it's missing here. So that I'm going to give it a weight of 10 to the address 00 hits and a weight of, I would say, 6, because it's easier. I think it's easier to change a phone number than to change an address, right? By phone number 00 hits. So I'm updating the trust score, which will change the ranking, right? Because I'm changing the formula underneath. Right. Yeah, so the distribution did not move too much, but it changed a little bit, right? So I mean, this is a better ranking than just ranking the um, by just ranking by the crypto payments alone, right? Then you can get, because you're looking at things that are not only on the location, that are marked in the person themselves, or in the firm itself, or in the case itself, right? In the party. So you're looking at more granular signals. But you can take this one step further, right? And then you can basically duplicate this. And this is why this is a nuclear weapon, because you can change the aggregation of this, the aggregation level. What is the pivot? Right now it's the attorneys. But if I change this, and instead of the representative, I look at the party, right? Wow, this is interesting. Yes, so this Branson guy with this child whose initials are JR, right? So it's something with the mother. Um, the child is being targeted, right? See, the child ranks higher than the mother because the child has a name marker junior. The mother doesn't, right? Um, I don't know. I really hope that authorities investigate this. But okay, so this is not on the attorney. This is on the party, right? And we can do the same with the firms, right? We just have to change the pivot. What I'm showing you here is how scalable this process is, right? You can just by 2 clicks switch your entire view of the problem from attorney to party, from party to firm, and from if I ingest the dockets, I can do this with the judges, right? Because I didn't ingest the judges, right? I didn't do it not because there's any technical limitation. I could have, but to be respectful, right? I am respectful of the judiciary system, and I, didn't want to. But if they keep not addressing my motions, right, I will have to keep debugging this deeper. I will have no option, right? So party. So you can do this the same with the firms, right? By just changing the pivot point, right? So instead of selecting party here, you can select the firm. Oh, I did not select the firm. The problem is that here in my query, I do not have the firm. I think. Let me see. No, it is there. It's called law firm. That's the problem. Let me see. Yes. Let me see. Should be there. Let me think about this for a second. If I go to this table, yeah, the law firm is in there. For example, right? This one. Let me see. Let me try to add a new table from scratch. Could be because of the, could be that. I think it's because the field name has a space, and that the studio doesn't like that, doesn't allow spaces in the field names. I should have thought of that. So what I'm going to do, I'm going to close this here. And I'm going to go back to my query, to my hit counter query, right? And I'm going to add another field that represents the law firm, but with an underscore, right? And I'm going to do that. And here I'm going to go back to what I'm going to go here, manage other data sources, hit counter. I'm going to refresh the field, so I get the new field, right? That is called law underscore firm. I'm going to click done, close. And in this table, I'm now going to select that. Yes, that's the reason. So I'm going to get the law firm, and then instead of record count, I'm going to compute this score V1 that I have, right, which is the network clearance score multiplied by the crypto payments. Okay. And then I'm going to sort by that score, descending. Right? So if you aggregate this one that says lawyer, I think it's because in the docket they didn't put the firm, they just said lawyer, right? But if you aggregate by a firm, this one, Mills Shirley LLP, is the one that has the highest aggregated score across all these dockets in the first appellate court. So you see, it's different ways of seeing the same problem, but with the same lens. Right? That's what I'm doing. Switching the subject, but keeping the same lens on. And I can do this very quickly, right? So anyhow, I think it's a good point to stop this part of the demo, right? And I would like to offer you a few other observations that I have. Yes. So this one is about this technique, right, of counting hits on different things. This is something that it's called. This is not a proprietary technology or anything. Like this is just a common technique of information retrieval systems. At Google, the system that does something equivalent to this is called Union, right? Union and the ranking system that is those two systems are controlled by a group of individuals, right? And I'm telling you this because this design, I can recognize it because I saw it there, right? Like this group of individuals control the equivalent of this in Google. And I can see how they took, the network, right? Took what they were doing at Google and applied to this, right? It's obvious to me that the similarity is striking, right? And unfortunately for them, that's the reason why I can say it. So I want to offer you the list of individuals at Google that could help the FBI investigate this, right? So I'm going to read you the names. The individuals are Isao, right? He is the manager, or was the manager of the Union team, and I know for a fact that he has done things against my website, right? At Google to de-index my website. So Isao is for sure part of it, right? But you can also talk to Michael Schubert, Mayur Thakur, Hila Becker, Oksana Jack Nenko, Jihua, she's probably a Chinese agent, Fang Shu, Andrew Hyatt, Andrena Kool, David Reis, they are from Belo Horizonte, right? But I think Andrena Kool migrated to the US and is now working in finance, right? Ranbir Kumal, who was, I think he left for Snapchat. and importantly, Gillian Walsh, because Gillian Walsh, I believe, is the person that recruited them into this, right? Circa 2012. And Gillian Walsh is a prominent attorney in New York City. And she used to work for a firm called SWA Legal. And SWA is an important network marker in this network that was identified months ago. Also, oh, I forgot to do that. We should probably do this as well here, right? So you can also score by case, like that's the other nuclear weapon you have. You can copy this, right? And now let's score the cases and see which are the most interesting cases. I'm guessing it's going to be the deep water, right? The deep water case. Well, not necessarily, because the crypto payments of Chris Branson are so high. When we, maybe that means that we should tweak that formula, but I'm not going to do that here. So here you can aggregate by cause. Oh, it's not here. Okay, so I have to add it first. Yeah, I didn't add it. So I'm going to say cause number. What is it? Right. And also, now that we're here, we can also aggregate by the trial court. That could be interesting, right? By the trial court judge and by the, I think it's called case number, I think. I can't recall. Yes, this one. Court case is called, right? Oh, I think it's because they already selected. Right. So I really need to add them, but it's in the. Okay. I need to add them here. Okay. Sorry, I'm getting an error here, but I don't understand what it is. Oh, there's two cost numbers. Okay, this shouldn't be needed. Okay. So I'm going to run it. And then I'm going to go to Data Studio again, and I'm going to refresh the fields, right? So these new fields that I'm adding get applied. And now I'm going to be able to do the same thing, but I'm going to aggregate at the case number, at the trial court, etc., right? To see which are the ones that are, because this is just a hunch, right? But what I think could be happening is, in some of these cases, right, where they want to move a lot of money in between parties, it looks more organic if there is first a trial case that goes one way, and then it goes to appellate, and there's appellate review, and the appellate review because this would be something that is stamped twice by two different courts, right? Authorities will not suspect that this is a way of moving money around. So it could be a way of legitimizing these transactions with two, stamps from two different courts at two different levels. Right? It looks organic. Like, I mean, who is going to question this, right? But of course, if you're seeing this data, you're going to question it, right? Because you're seeing that there's collusion between everybody, right? But of course, that's something that probably authorities need to investigate, right? It's not my. I'm just here to show you how I would, debug this, right? So this one that I have here is cause number, okay? So what I'm going to do, I'm going to change the pivot point for cause number. So the cause number is the cause in the appellate court, right? This is interesting. Oh, I don't know. Let me see. So one thing that you can do here is you can go to Texas courts and see what is that case, right? You can go to the First Court of Appeals, do case search here, and enter that case. Look at this. Wow, this is amazing. These are the things. These are the kind of things, right, that I see, and I get the chills, right, when I see this. What are the chances that this is the case that came on top? It's a case in which they're terminating the parental rights of somebody, right? It's exactly what they're doing to me, right? Exactly the same thing. It's the same TTP, right? The interesting thing is that this case, they did not terminate it, right? Quickly. They went through it in a month. From November 13 to December 8th, in less than a month. And this is in the Department of Family and Protective Services. Robert J. Hazerlin Shad and Jennifer Alvarez Smith. And Chris Branson is representing the child. Imagine that. And the child, this is a child that is marked with the junior marker, right? And this was done in the 313 District Court. And the case reported was Stephanie Wells. I don't know. Let's see who is that judge. Is Judge Natalia Kokinos Oaks. I don't know. I have to read this case. I have to. I feel compelled to do it. But if you aggregate by case, the chilling part of this is if you aggregate by case, it's a case exactly like what they're doing to me. And Chris Branson is representing the child. And Chris Branson is marking this database that I got from the Venezuelan intelligence services a year ago that has crypto payments marked, and his score is in the millions. I don't know. It's just a lot to think about, right? So I'll take a day or two to think about that. And there's other cases, right? But you can repeat that by the case number. Now, you can also do the same by the trial court, right? Now, this is something I wanted to look at because that number 133, I think I saw it before today. Let me see. Wow, this is quite a coincidence. This is quite a coincidence. So Judge Hittner from the federal court, which I'm going to talk to you about in a second, was a judge in this very same court, the 133rd court. And he was appointed to that court in 1978. Imagine, before I was born. I wasn't born yet, when he was already a judge in this same court, the 133 court. And he was appointed in 1978 by the then governor, Dolph Briscoe Jr. Note the junior in the name, right? And then he was later appointed to the Southern District of Texas, the federal court, in 1986. We're talking about almost 40 years ago, by President Ronald Reagan. So Judge Hittner is a very senior judge, right, in the federal court system. And he's the judge that is handling my case against William Kyle Adams and Troy Pickett and the police officers of Fort Bend County. So he was a judge in this very same court, the 133rd court, which is the court that handled this case where the parental rights of somebody were served not too long ago, right? And this ended up being in the same court of appeals where Justice Adams is the Chief Justice. It's a lot of coincidences, right? And all this, we got here to all these coincidences by just applying engineering and software based on the Google things, right? That this group of engineers at Google developed for Google, but applied to the geo index that the Venezuelan intelligence gave me last year. So it's impossible not to see it, right? So I think this is a good point to talk about Judge Hittner, right? So what happened was, and this is, I put it in the bucket already. I'm going to show it to you here, right? So I'm going to go to the bucket, which is storage. So if you go to court evidence, to this folder, and then you click on Federal Court, Southern District of Texas, the sequence that happened this week was that I filed this consolidated emergency motion, basically because the clerk has not issued the summons. When you file a case in federal court, the procedure, and this is dictated by procedural rules, the procedure is that the clerk has to issue summons, which authorize the person filing the lawsuit to serve the parties, right? Without the summonses, I think it's a plural form, you can't serve them, right? And if you do serve them, then that could be called into question by the opposing party, and they could get the case dismissed based on that the service was improper, right? So I'm asking Josh Hittner, because the clerk has never issued a summons for this case. For the other case against Elon Musk, they did. But for this case, they didn't, right? The case against William Kyle Adams, where there's all this evidence, and I filed the evidence of the fraud against the two Texas courts in this court, right? In this case. So I'm asking the judge, Hittner, which is the same judge that was a judge in the 133rd court, right? 40 years ago, appointed by the governor of that era, that had the name marker Junior. So I'm asking the judge, my motion is to ask the judge to order the clerk to issue the summonses, right? Like the order to serve people in this case. I also ask him in the same motion to please allow me access to file electronically, because they are manipulating my ability to receive mail at my two houses, right? And this is described before, and it's in the docket recorded that my mail is bouncing back to the court. The court is sending me correspondence, and USPS is sending it back to the court, marking my address as undeliverable, right? So there's proof in the same docket that I cannot receive mail, right? And I'm asking to be allowed to file electronically. Well, I also asked to stay the conference for January 27th. And because, if I can't serve them, how we're going to have a conference if I cannot serve the other parties, right? And I'm asking also to withdraw my consent to the magistrate judge. So anyhow, I filed this, right? Which the most critical part is the summonses, right? Because if I cannot serve the parties, how are we going to move forward in this lawsuit? This is a fundamental requirement for the lawsuit to progress to the next step. And Judge Hittner denied all the motions. the next day after I filed them, right? So, and here is the order, right? You can see the order. I put it in here. Right? He denied everything, right? Without explaining why. Like, there's no rationale for this. It's just denying everything. But the most critical thing is that he denied the motion to ask the clerk to do his job and issue the summonses, which are a prerequisite for me to serve the other parties. So in effect, this order is blocking me my ability to even get access to the federal court. Like, this is blocking the entire case, right? Because if I cannot serve them, how can we have this lawsuit, right? So I mean, in my mind, right, I would contend that this is a way of obstructing my access to the court, right? And especially the other one, the denying my ability to file, the permission to file electronically, which I understand is a privilege. It's not a right, right? But if there's proof in the docket, and you can see that because I also put the docket in here, right? I also added the docket to this folder. So this is the docket, right? So if you look at the docket, you can see, for example, in the index 28, that mail was returned, right? So they have proof in the docket that I don't have access to the USPS mail system because it's been blocked. And still, in light of that evidence, they're denying me access to file electronically, which severely affects my ability to get access to the court and to interact with the court. But more than that, the judge also denied my motion for the issuance of the summonses, right? Which it's a procedural requirement for the lawsuit to progress, right? So in effect, what they're doing is blocking me and blocking my access to the court, right? But this is good news, right? Because this means masks are off, right? Like, before, the cases were stalled, but there was no smoking gun. Like, there was no evidence that this was a deliberate design. But I think at this point, right, if they're openly blocking the summonses, and he also struck from the record the second amended complaint, in which I named William Cal Adams and added evidence of the fraud against the two courts. So he struck in a separate order, in the same order, really. And he says here, right? The court further orders that plaintiff's second amended complaint for violation of civil rights, so my complaint has been struck, imagine that, right? Is hereby struck without hearing, right? He didn't even give me the opportunity to be heard, right? He just struck the complaint. So I think this is very serious, but it's also very good, right? Because now, things are unblocked, right? Now I can move forward. So, this is exactly what I mean. But I want to document here that all this sequence happened, right? So there's no doubt of what happened. Yes, so I have also a couple of notes that I want to record here. One is about an incident that happened on September, I think it was September 4th, if I recall correctly. September 4th, 2024. So this was exactly 1 week before I got a copy of the database of the Venezuelan intelligence with the crypto payments and everything. I'm not going to get into much detail here. This is described in the books, but there was an instance in which an agent that seemed to me like he was probably Russian, right? Because his skin color and the way he talked. He trapped me inside of the parking lot of a company called Clear Channel Outdoor Holdings here in Texas. And this is recorded in video, and the video is posted in YouTube. You can watch the video if you're curious. You can go to, this is one of the short links that I implemented, right? So you can go to the spyhellfiles.com/clear-channel. That will redirect you to that video. And you can see the man, that's the man, right? That he trapped me inside of that parking lot. He closed the gate so I could not, and this is an attempted kidnapping, right? He did not put a gun to my face, but he trapped me in that facility. Now, this is interesting because Clear Channel Outdoor is a company that has been accused by the SEC, by the SEC, of bribing Chinese officials and members of the Communist Party of China. And this is exactly the same group of people that I am alleging are orchestrating all this, right? And it is recorded in this video how they entrapped me inside of this facility, right? Which has been accused of bribing the Chinese members of the Communist Party of China. Of course, I understand now that they're not bribing them, right? They're just cashing out, meaning they own that company, right? And I'm telling you that based on the data in the index, right, in the UA index. It's not a bribe. It's not a bribing scheme. It's a cash cow, like it's an ATM. Like they're just withdrawing money from their entity. They own that company, right? So I just want to record that here. And the other two things I want to mention briefly, I'm not going to get into much detail because like this is, for me, it's a bit hard to talk about this, but the Venezuelan informant told me yesterday. So I asked him a question about whether, so my two grandparents, my paternal grandmother and grandfather, they died a few years back. I think it was 2018 and 2019. I can't recall the exact years, right? But I asked the informant the question if the network had anything to do with this. And yesterday he told me, I was going to give this demo yesterday, but honestly, after he told me that, it took me a while to process this, right? He told me that yes, they were basically murdered, right, by the network. And the goal, this is what the informant told me. I have no way to, prove if this is the case or, it's just please take it as a tip, right? But what he told me is that it was a way to make my parents leave the country because they wanted to move Nelio Espina and the Espina family outside of Venezuela to the US. But they couldn't do that as long as my parents were there, because then my parents would see that they had moved to the US, right? So what they did is that they got rid of my two grandparents, so my father would leave the country. And then after that, they moved Nelio, right? So this is what the informant told me. I don't know if this is true or not, but this is what I got. And the other thing I want to tell you is that, and this is not from the informant, I'm telling you this from the data I'm seeing in the UA index. The Wuhan Institute of Technology, which according to certain scientists is suspected of being involved in the creation of the COVID virus, is marked in the same database with the crypto payments that I've been talking about through all these 8 months. Right? In the same database, the Wuhan Institute of Technology is marked with crypto payments and espionage scores. So this is something that I think calls for an investigation of at least the FBI, right, at a minimum, right? So I want to also mention that here. So I think this is a good point. And of course, I offer to give more information about these two last things that I mentioned to the authorities if they come and talk to me in person. But I feel like these topics are, topics that are very serious and are better discussed in person. And I'm more than open and happy to offer all the information and help I can in these two topics specifically. So I think with that, I'm gonna stop this demo here because it's getting to the 2.5 hours mark, and I'll I'll make a follow up with the other items that I had. Okay. Well, so thank you so much for your time, and I'll see you on the next one. Bye.